Now I want to talk about the interaction between quantifiers and some of these other logical connectives, implication and and. And I mean, we can bring in other ones too, and we will at some point, but these particular ones are really interesting the way they behave and useful for forming the kinds of sentences we might want to form. Okay, let's start with this one. For all x, x is a flower and x is green. Now, pause the video and see if you can state this without mentioning x. Okay, here's the answer. You could say everything has the property that it is a flower and it is green. Or maybe a smoother way to say that is everything is both a flower and green. Or maybe even better actually, everything is a green flower. So that's what this one says. So let's make some little pretend universes where in each of these boxes I'm going to draw some pictures of objects, and each box represents like a universe where everything inside the box are the only things that exist in that universe. And so whenever I say for all x blah blah blah, you can interpret that in terms of a particular universe that I'm drawing, just for the sake of an example. So let me fill in this universe with some objects. Okay, so now this universe has exactly 6 things in it. It's got a smiley face, this guy, a white flower, a book, a paper, and here's a green flower. And would you say that in this universe everything is a green flower? Absolutely not. And there are many reasons that you can cite for why it's not the case that everything is a green flower. There are things that are not flowers, there are things that are not green, and in fact the only thing that's a green flower is this one thing back here. So it's definitely not true about this universe that everything is a green flower. Okay, what if I get rid of these objects? Is it true now? Well, it's true that everything is a flower, but it's not true that everything is a green flower. Okay, I've modified it so that it only contains green flowers, and now this universe has this proposition here being true. So that's what happens when you put a for all with an and. You sort of require that both conditions hold for everything. So now I'm going to look at basically the same proposition, except it's very different because I've changed the connective here to an implication. So how would you read this? So see if you can find a way to read it without mentioning the bound variable. Okay, and here is the answer. So it would be, so mentioning the quantified variable, you can also call it a bound variable. Mentioning this variable, you could say for all x, if x is a flower, then x is green. How about not mentioning it? Everything has the property that if it is a flower, then it is green. So that would be a long-winded way of saying it. Everything has the property that if it is a flower, then it is green. Maybe a better way of saying it is everything that is a flower is green. Or an even smoother way of saying it, I think, is to just say all flowers are green. So can you make that feel intuitive for yourself? That all flowers are green is the same as saying everything has the property that if it is a flower, then it is green. Now let's look at how this would work in a little mock universe. So let me populate this with objects. Okay, so here I've put in this white smiley face, white book, white guy, red smiley face, green flower, this green cat, and this other green flower. Then would you say about this world that all flowers are green? Well, if I say it that way, if I just say all flowers are green like that, probably you would agree with me, right? All flowers are green in this world. How about checking sort of item by item whether this is true? For all x, if x is a flower, then x is green. Well, for this to be true about the universe here, for this to be true, it has to be that this proposition on the inside is true no matter what I replace x by. So it should be true when x is replaced by the smiley face. It should be true when x is replaced by the book, by the person, by the other person, by the flowers, and by the cat. So I have a total of 1, 2, 3, 4, 5, 6, 7 instances of this proposition to check whether they're true. And probably you agree with me that the proposition is true when I focus on the flowers. So if I take x is a flower, implies x is green, and I replace the x's by this flower here. Okay, so say I replace the x's by the actual flower there, by this one or by this one, then definitely this implication is true, because it's on the left side we've got this thing is a flower, that's true, it is a flower, and on the right side we've got this thing is green, and that's true. And so the implication overall is true. But what about when I replace it by something else, some other object from the world? Like what if I replace it by the red smiley face over here? Then is the implication true? Actually, yes. It is true because this is not a flower. So it is vacuously true. So because this is false, the implication as a whole is true. And I hope you can see that as you go through and check every item, you're going to get true, 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 true 7 times. So this statement, for all x, if x is a flower, then x is green, really is true about this world. And that agrees with our interpretation, of our way of reading this as all flowers are green. If you want to make this false, then what should you do? You should introduce a non-green flower, right? Like this flower here. Then suddenly, this statement up here becomes false, because when I put this flower in for x, then what do I get? I get true here. The hypothesis is true. It is a flower, but it's not green. Now this is false. And so overall, I have the implication is false, which makes this for all false. It's not the case that everything has the property that if it's a flower, then it's green, because this thing does not have the property that if it's a flower, then it's green. Everything else, however, does. So what I want you to take away from what we just saw is an interesting fact about how implication and for all work together. So say you have this statement, for all x, x is green. This says everything is green. But maybe that's not what you're trying to say. Maybe you're trying to say that not everything is green, but everything from a certain class of other things is green. So say you're only trying to say all flowers are green, not everything, just the ones that are flowers. Then we have seen that you can do this. For all x, if x is a flower, and you put this implication symbol, the if then x is green. And all those features we saw about implication and how it can sometimes be vacuously true, they may have seemed silly back then, but now I hope you see that they're actually quite useful ways for implication to work, because thanks to the way vacuous truth works for implications, this becomes a valid way to say all flowers are green, rather than everything. No, not everything, just the flowers. All flowers are green. So you can think of, the way I describe this is, it's a way for quantifying over fewer things. Instead of saying for all things, x is green, you can say for all flowers, x is green. Now, what if you want to do the same thing but with existential quantifier? You want to say there exists, you don't want to just say there exists a green thing, you want to say there exists a green flower. Among the flowers, there's a green one. Well, to say there exists a green flower, you can just do this. So you say there exists X such that X is a flower and X is green. So the and here works well in order to make your existential quantifier sort of quantify over fewer things. Instead of saying just there's a green thing among all the things, you're saying specifically among the flowers, there's a green one. There's a green flower. Or there exists X. There exists something that has the property that it is both flower and green. And based on what we previously saw back here, with implication being a good way to make a universal quantifier quantify over fewer things, based on that, you might have thought that an implication symbol would work well here, but it just doesn't. And to see that it doesn't, maybe I'll leave you with a little puzzle here. So say you try to use an implication symbol with an existential quantifier in an attempt to quantify over fewer things, and you write this. So I would read this as, there exists something with the property that if it is a flower, then it is green. Something has the property that if it is a flower, then it is green. Now, I would say that in this little universe with three objects, the statement here is true. Even though there are no green flowers, it's still true. What's written here is still true. So can you see why it's still true?